In the pursuit of progress and prosperity, we often find ourselves at a crossroads where our actions threaten the very ecosystems that sustains us. A question I constantly keep asking myself is how life would be without industrial pollution after 30 years. Let me introduce you to my artificial intelligent assistant, Brian.
Hi, my name is Brian.
Diving into the topic, the use of a good fuel additive gets us one step closer to where we want to reach. For instance, using methoxymethylheptane instead of methyl tert butyl ether because it presents a promising avenue for enhancing environmental sustainability through innovative production process, particularly in the domains of all three: energy transition, circular economy, and resource efficiency, which leads us to our project.
Modeling and control of separation units of methoxymethylheptane as an environmentally friendly diesel additive. Since this topic is not constricted to any one of the three challenge themes, if I had to choose one that resonates more than the other, I would pick energy transition and decarbonization because MMH contributes to a reduced carbon footprint of diesel engines by improving the combustion efficiency,
Which facilitates a smoother transition from traditional fossil fuels to a more sustainable energy solutions. This is very crucial in mitigating climate change impacts.
Stop beating around the bush and cut to the chase.
Haha, okay. The process involves modeling and controlling the separation units to optimize the purity and yield of methoxymethylheptane, or in short, MMH, thereby enhancing its effectiveness as a fuel additive. The production of MMH involves the reversible reaction between methanol and 2-methyl-1-heptene in the liquid phase. This reaction is vital in the formation of methoxymethylheptane, which is our desirable product. However, there must occur a side reaction. In this case, it produces dimethyl ether and 2-methyl-2-heptanol. These products will pass from the reactor to distillation columns where they are separated depending on the difference in boiling points.
As for the HYSIS model, it involves taking the products formed from the reactions and entering them into three different separation columns. This is done primarily to increase purity and to make the most of the important compounds that were produced, which in this case is MMH, and lastly to effectively dispose of the other products.
Methanol and 2-methylheptene enter the reactor at 400 Kelvin and 15 atmospheric pressure, producing methoxymethylheptane. However, also, dimethyl ether and 2-methyl-2-heptanol can be produced in the side reaction. These products then enter a series of distillation columns where they are separated depending on their boiling points. Since dimethyl ether has the lowest boiling point at -24 degrees Celsius, it will vaporize and exit at the top. Small traces of it can still be found at the bottom. What about our desirable product, Brian?
Our desirable product have a higher boiling point, so it will exit at the bottom with traces of impurities, but at low compositions. Consequently, it will enter separation column 2 and 3, and then finally MMH can be collected and used further. This process in its entirety is tailored to maximize the recycling process and reuse the byproducts. This approach not only conserves resources, but also reduces environmental pollution, aligning with sustainable industrial practices. Change can be expensive sometimes, we can't deny that.
True. Let me get into the details. Advanced control strategies in the separation units ensure that the consumption of raw materials and energy is kept to a minimum. This cut production costs and also lower the ecological footprint of the manufacturing process. In conclusion, this study has proven methoxymethylheptane superiority over methyl tert butyl ether in combustion efficiencies, which leads to better mileage and reduced fuel consumption, not to mention how helpful it is in reducing harmful emissions such as nitrogen oxides and particulate matter from diesel engines. This is particularly important for meeting environmental regulations and reducing the ecological footprint of diesel engines. This leads me to my final point that this responsibility is a big one, and one person cannot make a difference, so let us all pledge to leave planet Earth better than we found it, and to ensure that future generations inherit a world rich in beauty, diversity, and possibility. For in the end, our true measure of success will not be counted in profits, but in the health of our planet.